So today we are going to cover Chapter 1, Section 4A. We're going to split Section 4 into several days. Today we're going to solve by factoring and by using the square root method. So when we solve by factoring, we need to get all of the terms to one side, setting the equation equal to 0. Then we're going to factor the equation. And then once we get the factors, we're going to set each term equal to 0 and solve for the variable. So let's go ahead and take a look at some examples. So basically, we're going to do what we did in the prerequisite chapter. We're going to factor the polynomial, whether it's a trinomial or a binomial or a 4-term polynomial. We'll factor it. And then we take it one step further and set those terms or those factors equal to 0. So here's our first example. Notice it's already set equal to 0 for me. So now I'm going to factor the difference of two squares. So these are both perfect squares. This will factor into x plus 1 and x minus 1. Now that my binomial is factored, I need to set each one of the binomials equal to 0 and solve for x. I'm going to subtract 1 from both sides on this one. So my first solution is x equals -1. And then my next one, add the 1, and x equals +1. Now, you may see things on a standardized test, and they may show it as the plus minus symbol like this. But again, WebAssign is going to tell you to enter your answers and separate them with a comma. So when you enter this in WebAssign, you would do like -1, +1. So just read the instructions when you are going to go ahead and enter it into WebAssign. Now, what you're going to see moving forward, because like I said before, we will factor all year long. We're going to start quadratic equations where we're going to be graphing them and finding the x-intercepts or the solutions. This is the same thing. These two numbers that I just got, these are actually my x-intercepts. So when I go to graph this, this is where this parabola or the graph of this quadratic equation is going to hit the x-axis. So again, we're going to be using this again moving forward when we start graphing quadratic equations. Let's try the next one. Notice my equation is already set equal to 0. So all I need to do is factor out my greatest common factor. And my GCF here is going to be x. So I can divide both sides by x. And then now I'm left with x times 3x plus 1 equals 0. So now I'm going to go ahead and set each factor equal to 0. So I'm going to set the x equal to 0 and the 3x plus 1 equal to 0. The first one's already solved for me. I need to go ahead and solve my second one. So I'll subtract 1. I get 3x equals -1, divide by 3, and my second solution is x equals -1/3. So again, when you enter them into WebAssign, you're going to enter both answers separated by a comma. If you notice, both of these examples had an x squared. This is a clue how many solutions you're going to end up getting. So notice my highest exponent was an x squared, so that was a clue that I'm going to be looking for two answers. Now, sometimes the answers are the same number. For example, if you're factoring a perfect square trinomial, the numbers will be the same. And when we go to graph things like this, it's not going to be a x-intercept where it's going to cross through an x-axis. We're going to see that it's going to be a touch and turn. It's going to bounce off the x-axis when a factor or when a solution repeats. But that's coming up later. All right, so let's try the next one. Again, you need to set your equation equal to 0. So I need to subtract x from both sides. So if I subtract x here and here, I now end up with x squared minus x equals 0. I need to look for my greatest common factor. My GCF is x, so I can divide both of these by x. Write the GCF, write what you get after you divide, and now set each one of these terms equal to 0. So the first one will be x equals 0, and then the next one, x minus 1 equals 0. I need to add 1 to both sides, and x equals positive 1. So my two solutions will be 0 and positive 1. So these were nice and easy. They were just GCFs. Now we actually have a trinomial that needs to be factored. So on this one, I am looking for factors of -8 that when I add them will give me a positive 2. And those factors of -8 will be positive 4 and -2. When it's the nice, easy trinomial, I don't have to factor by grouping. I can go right into my two binomials. If you prefer to factor by grouping, you can still do it. But when that a value, the number in front of x squared is a 1, go right into your binomials. So then now I set each binomial equal to 0. So x plus 4 equals 0, x minus 2 equals 0. Subtract the 4. My first solution is x equals -4. And my second solution is x equals positive 2. Okay, so for number 5, this is a more challenging trinomial. You could still do guess and test if you choose, but I'm going to go ahead and do the factor by grouping. So I'm going to multiply the first term times the last term. So I'm looking for two numbers that will multiply to give me -30, but who will add to give me the -1 in the middle. Whenever I see that middle term is a 1 or a -1, that's a clue that my factors are going to be consecutive, side by side. So I could start my list of -30 factors. 1 times -30. The sign of the middle goes on the bigger factor. 2 and -15. 3 and -10. And then here is my combination I need. The 5 times -6, and then plus 5 plus -6 gives me the 1. So these are my two factors, positive 5, -6. I'm going to rewrite the first term, the 2x squared. I'm going to replace with the two factors. Doesn't matter the order you put them in. I'm going to put the -6 first, then the 5. Now I've changed my trinomial into a 4-term polynomial. I'm going to make two groups here. I'll make a green group and a yellow group. So my greatest common factor here of green is going to be 2x. So I'm going to divide both of them by 2x. And then now I'm left with x minus 3. My greatest common factor of the yellow group is going to be 5. Divide them both by 5. And then after I divide, I end up with x minus 3. Notice these both look the same, so write it down once. Take the two GCFs, put them together in your other binomial, and now set each of the binomials equal to 0. So I'll do the first one, x minus 3 equals 0, then the second one, and then I have to solve each binomial for x. Add the 3 on the first one, x equals positive 3. Over here I'll subtract the 5, 2x equals -5, divide by 2, and x equals -5/2. So same thing we did in the prerequisite chapter. Once we factor, we take it one step further and set the binomials equal to 0. If WebAssign says put the smaller answer first, the -5/2 would go first. If it doesn't open up that equation editor or that math pad, you would do this, and then a comma, and then a 3. All right, remember, this one was already set equal to 0, but when I look at number 6, it is not set equal to 0, so I need to subtract 3 from both sides first. So then now my equation is 2x squared plus 9x plus 4 equals 0. I'm going to factor by grouping. There's no GCF here, so I'm just going to multiply the beginning and the end. So this is going to give me two numbers that'll multiply to give me an 8, but who will add to give me a 9. And that's going to be 1 times 8, because 1 times 8 is 8, and then 1 plus 8 is 9. Rewrite the first term. Replace the 9 with the two factors you just found. So a 1x and an 8x. I don't necessarily have to put the 1 in front of that 8, but I'll go ahead and put it there. So now I'm going to look for my groups. So I'm going to make my two groups here. So I got my first two. I'll put those together in green. And then I can do these two, do them in white. All right, so my GCF of green is just going to be an x. So I'm left with x, and then is the GCF, and then 2x plus 1. And then the GCF of that second group will be 4. So then 4, and then divide. And notice both of my results are the same. So we'll write this down one time, 2x plus 1, and then again, group the two GCFs together. Set each of your binomials equal to 0. So 2x plus 1 equals 0, x plus 4 equals 0, and now solve. Subtract 1, 2x equals -1, divide by 2, and x equals -1/2. And over here, subtract the 4, and x equals -4. So for number 7, set your equation equal to 0 first. So I need to subtract the 3x. And now my equation is 6x squared minus 3x equals 0. I need to look for my greatest common factor. My GCF here is going to be positive 3x. So if I divide that, put the GCF on the outside. After I divide, 2x minus 1. And now set each of your terms equal to 0. So I set the 3x equal to 0 and the 2x minus 1 equal to 0. Here when I divide, 0 divided by anything is just 0. Over here I have to add the 1 and then divide by 2. And x equals positive 1/2. So for number 8, we're going to do exactly the same thing. I'm going to set my equation equal to 0. So I need to subtract the 2x from both sides. I get 8x squared minus 2x equals 0. I'm going to look for a greatest common factor. My GCF here is going to be 2x. I'll divide both terms by the 2x. So write the GCF down, divide, and now set each term equal to 0. So the 2x equals 0 and the 4x minus 1. Here, when you divide 0 by 2, you just get 0. Here, add 1 and x equals 1/4. And you're done. So for number 9, remember your equation needs to be set equal to 0. Always try to keep your x squared term positive. So instead of subtracting x squared, I'm actually going to subtract the 6x. Add the 6x. Then add the 9. And now my equation is set equal to 0. This is actually a perfect square trinomial. The factors of the perfect square 9 are going to be 3 and 3 because 3 plus 3 is 6. So this is actually x plus 3 squared, but I'll write it twice. Now, you don't have to show the work of setting x plus 3 equal to 0 twice. Just do it once. And this is the scenario where you're only going to get one solution. Even though it was an x squared, this parabola is going to actually have its vertex sitting on the x-axis. So whenever you get an answer that repeats, you actually have x minus 3 twice. However, it'll be a touch and turn when we graph these. But for now, you're just trying to find the solution. This is also called a root. This is also called a 0. So this is where it's going to get challenging. Understand what they're asking you to find. Let's try example 10. This one's already in standard form, already set equal to 0. This is also a perfect square trinomial. Now, if you didn't recognize it, you could do it the long way, and you could go ahead and multiply, find factors of 36 that give you 12. But if you recognize that these are both perfect squares, then just square root these, and you would get 2x times 3, and then double it. And if it gives you the middle, which it does, then all you have to do is square root the 4x squared, square root the 9, and then it's a binomial squared. Or you can write it twice like I did before. And again, when you go to solve, just do it one time. You don't have to show the solving process twice because it's exactly the same work. So x equals -3/2. If you didn't recognize that 4 and 9 were perfect squares, you could have done it the traditional factoring way by multiplying the beginning and the end and then factor by grouping. That way works as well. Now, if you notice, number 11 looks like the same problem we did in number 4. However, the signs are different. So I'm looking for two numbers that multiply to give me a -8, but who add to give me a -2. So this is actually going to be -4 times +2. So this time the signs are different. So x minus 4, x plus 2. Set each of the factors equal to 0. You could do it by grouping as well, but whenever I see the number in front of x squared as a 1, I just factor it by finding the factors of that last term. Because really what we're doing is 1 times -8, and you really don't need to do the grouping. But again, for those of you who like consistency, you could still do the grouping. Two more examples of factoring. Solve by factoring, and then we'll move on to solve by using the square root method. All right, so for number 12, again, I like to try to keep my x squared term positive. Now, what I could do here is move the 3 over and then divide by a -1 to get my x squared term positive. So -1, divide all these. So -1 and then x squared minus 4x plus 3. I'm looking for two numbers that'll multiply to give me positive 3, but add to be a -4. And that'll be a -1 and a -3. Now again, set each piece equal to 0. Now when I take this number here and set it equal to 0, there's nothing to solve here, so I don't do anything with this one. Now, if that GCF that I pulled out had a variable, then I would have solved it. But here, all I have to solve is the x minus 1 equals 0 and the x minus 3. X equals positive 1 and x equals positive 3. Now, instead of trying to find factors of negative 1/8 and 16, clear the fraction first. So I'm going to multiply my entire equation by positive 8 to clear the fraction. So I'm distributing 8 to all three pieces. So then this will just become an x squared minus 8x minus 128. I am looking for two numbers that will multiply to give me negative 128, but who will add to give me negative 8. And that's actually the two numbers that are there, 8 and 16. So negative 16 and positive 8. If you didn't see that, then you would do your organized list. Set each factor equal to 0. Add 16. X equals positive 16. And then subtract the 8, and x equals negative 8. All right, so for the first one, it says solving equations by square rooting. So what we're going to do is get the square term to one side. We're going to isolate the square term. Then we're going to square root both sides. And remember, this time when we do it, we're going to get a positive and a negative answer in front of the root when we're done. We're going to be leaving our answers in simplest radical form on the quiz. Now, also, whenever you see the instructions, leave your answer exact. That means simplest radical form. Now, last year in geometry, whenever you did, say, Pythagorean theorem and you square rooted something, we never kept the negative answer because we never wanted a negative side length of anything or a negative angle. So that's why we never kept the negative answer. But now in Algebra 2, we're going to keep both the positive and the negative answer. So let's go ahead and try the first one. Notice my square term is already isolated. So I'm just going to take x squared. I am now going to square root both sides. Square rooting the x squared cancels the square, and now I'm left with x is equal to both positive and negative the square root of 15. Now, what you would need to do is see if you could break down the 15. 15 only factors into 3 times 5. I don't have any pairs, so that is exact. That is simplest radical form. Now, in WebAssign tonight, it's going to have 4 boxes. It's going to ask you to pull this apart. So you're going to have to show me negative square root 15, positive square root 15, but then it's also going to ask you for the decimal approximation rounded to 2 places. So this would be using your calculator, negative 3.87 and positive 3.87. So there's going to be 4 boxes that you'll fill in. You're going to first fill in the exact, which will be simplest radical form. Then you're going to use your calculator and then estimate it or round it to 2 decimal places. On the quiz, we are not using a calculator, so all answers will be left in simplest radical form. So for this one, already isolated, so x squared equals 48. Square root both sides. Square rooting a square makes the x come out. I now have both positive and negative, the square root of 48. 48 is not in simplest radical form. I need to break it down. It doesn't matter what you start with. I like to do 16 times 3 because I recognize that 16 is a perfect square and it goes to 4 square root 3. But let's say you didn't recognize that. Let's say you wanted to do 6 times 8. And then you got to keep going until you get to prime. So keep breaking it down. 2, 3, 2, and then 2, and 2. And then remember, now you go back and look for pairs. I got a pair of 2's here. That 2 comes out. I can make another pair over here, but then there's no pair for the 3. He stays underneath. Multiply these two 2's, and same answer I got when I had just done 16 times 3. So in simplest radical form, this becomes plus and minus 4 square root 3. So when you go to enter this in WebAssign, you're going to enter negative 4 square root 3, which is approximately negative 6.93. Then you'll enter positive 4 square root 3, which is approximately positive 6.93. I believe on this one it asks you to enter the smaller one first. So obviously here the smaller value is the negative number. Again, read the instructions. Whenever it says to leave your answer exact, it wants simplest radical form. Okay, it's not a decimal that's rounded. Notice this time my square term is a binomial. It's isolated. So I'll go ahead, take my binomial that's squared. It's isolated, so I need to square root both sides. When you square root that binomial squared, it just cancels the square and the 4x plus 1 comes out. And then over here, I'm left with plus and minus the square root of 20. I need to break down the square root of 20. Factor tree. Doesn't matter what you start with. Again, if you're good at recognizing perfect squares that are factors, notice it goes right to 2 root 5. You could have done 10 and 2. Doesn't matter, but you'd have to keep breaking down till it was prime. So now I have 4x plus 1 equals plus minus 2 square root 5. Now I need to work on isolating x. I need to subtract 1. 4x is equal to negative 1 plus or minus 2 square root 5. Still not done yet. Divide. And x is equal to negative 1 plus or minus 2 square root 5 over 4. On the quiz, you could leave your answer like this. However, WebAssign wants you to pull it apart. So you're going to, first answer would be negative 1 minus 2 square root 5 over 4. That's the exact. Approximate, negative 1.37. The positive value here with the plus sign, negative 1 plus 2 square root 5, divide by 4. And this one's 0.87. Notice this time, because something was being done to that radical, they're not one positive, one negative. They're actually two different numbers. So be careful, okay? And for the decimal approximation in the homework, you're using a calculator. It can be a basic calculator. It could be the calculator on your iPad. It could be the calculator on your phone, just as long as it's got a square root button. However, for the quiz, no calculator. Everything will be simplest radical form. So on the quiz, this would be your answer. Let's try another one. My goal is to isolate the square term. I'm going to add 43 to both sides. I get x squared equals 43. square root both sides, which cancels that, and I get x is equal to positive and negative square root of 43. 43 is prime. I can't break it down. So my first answer is the negative square root of 43, which gives me negative 6.96 or 6.56. Positive square root of 43, which gives me positive 6.56. WebAssign will say round to 2 decimal places, which is also, you might see it say round to the hundreds place. All right, number 18. Remember, your goal is to isolate the square term first. So what I'm going to do is divide both sides by 9 first. I get x squared equals 4. And now I square root both sides. And I get x is equal to positive and negative 2. So again, in WebAssign, negative 2 would be the exact. Negative 2 would be the decimal rounded to the hundreds place. So again, you're still putting in just the same thing when it's actually a perfect square. So the exact and the decimal are the same. 19, same thing. Isolate the square term first. Divide both sides by 25. I get x squared equals 37 over 25. I need to square root both sides. Square rooting the x squared cancels it. So now I'm left with x is equal to positive and negative the square. And I could pull these apart because watch what will happen here. I can actually square root the 25, and this will give me positive and negative square root of 37 over 5. So my first answer will be negative square root 37 over 5. The approximated decimal is negative 1.22. And then positive square root 37 over 5, which gives me positive 1.22. So for number 20, again, you're going to square root both sides. My square term is a binomial, and that's okay. So we're going to square root it, which cancels the square. So the x minus 5 comes out. The square root of 25 is positive and negative 5. Now, what I need to do here, I could do it this way, and then get x equals 5 plus and minus 5. You can't leave it like this. You have to do the two problems. So x equals 5 minus 5, and then x equals 5 plus 5. So 5 minus 5 is 0, and then 5 plus 5 is 10. So again, the decimal would just be 0. The decimal would be 10 for the 10. So when your answer over here is a perfect square, you actually have to simplify it. You can't, on the quiz, just leave it like this. You have to do the two problems and give me the two integer answers. Now the next one's going to have a radical. So for the next one, x plus 9 squared equals 24. Square root both sides, cancels the square, so the x plus 9 comes out. Positive and negative square root 24. 24 is not a perfect square, but it's got some perfect squares hiding in there. So let me do a factor tree. Doesn't matter if I do 2 and 12, 3 and 8. I'm going to do 4 and 6. Doesn't matter. 2 and 2, 2 and 3. Notice you got a pair of 2's. 2 comes out. These guys don't pair, so put them back together. So this becomes x plus 9, positive and negative, 2 square root 6. I need to subtract the 9, and x is equal to negative 9 plus and minus 2 square root 6. Again, WebAssign expects you to pull this apart and give the 4 answers. So the first one, -9 minus 2 square root 6. That decimal approximation is going to be -13.90. -9 plus 2 square root 6. That decimal is -4.10. 22. Again, my square term is already isolated. So all I got to do is square root both sides. Square rooting this cancels it. So the 4x plus 7 comes out. This becomes positive and negative, square root of 44. I got to do the factor tree. So for the 44, I could do 4 times 11. If you notice 4 is a perfect square, just square root it. So this becomes plus and minus 2 square root of 11. So then now I can work on isolating x by subtracting 7 first. And then divide by 4. So x is equal to -7 plus and minus 2 square root of 11 over 4. Again, for WebAssign, we're pulling it apart. So -7 minus 2 square root of 11 over 4, which is approximately -3.41. And then we have -7 plus 2 square root of 11 over 4, which is approximately 0.09. All right, so for the last one, remember your first step when you're solving using this square root method is to isolate the square term. I can't isolate it, so what I'm going to do is have to FOIL both of these sides and then just combine like terms. So I cannot apply the square root method on this problem. So I'm going to write down each binomial twice and FOIL it. So I get x plus 5 times x plus 5, x plus 4, x plus 4. I'm going to FOIL this one. X squared plus 5x plus 5x plus 25. I can add those middles, and I get x squared plus 10x plus 25. I'm going to FOIL the other side. X squared plus 4x plus 4x plus 16. Add the middles. And now begin combining like terms and move them across. So as soon as I try to subtract x squared to move the x squareds together, notice both x squareds cancel on both sides. So then you're left with 10x plus 25 equals 8x plus 16. I'll now try to move the x's together by subtracting 8x. I end up with 2x plus 25 equals 16. Subtract the 25. (2x) equals -9. Divide by 2. And x equals -9 over 2. WebAssign will let you enter it as a fraction.